you just had enough information on some of those papers you turned in. So, double check your homework. If you are missing something, turn that in as soon as possible. We're going to go through test scores right now. So I'm going to put it up on the board. You guys know the drill. I'll make fun of you. It's going to happen.
Why do you have so much?
That's how I get my jolly.
Which one?
He didn't write his.
Alright. So, people that still owe me something. Luke, Ryan, you guys owe me at least one item.
No.
Are we going over the
Ryan,
test?
you never turned your page 42, or maybe, yeah. So,
What did I
that
not
was the
do?
reason.
You kidding me, Sam?
Did you get a haircut?
Or what I did not do?
Page 33.
What I did not do.
I need it.
By what?
As soon as possible.
Did I see my
Alright.
test?
Scared me.
Like by
You know,
next
it's supposed
week?
to be
No.
It's a don't look past.
You get it done today. You get it done. So,
Am I not?
alright.
Oh, I gotta stay on it. Don't go there.
It's probably bad.
What I'll do is stay on
Leave that
next
out.
day. What on check
It's not bad, but
I
Should I put homecoming for activities on
no.
What?
Homework is
Your favorite memory.
Alright, next.
becoming the homecoming.
Test scores. Okay,
What are they gonna do?
Alright. Hey, you're gonna get your test back here in a minute. Do not crumble these up, these are mine. I would like you to turn them in when we're done, so don't crumble them up. You have 1 week from today to retake. That means you're not coming in here next Monday and expecting to review and take it. You have to review this week, and the latest you can take it is next Monday. So you have to have a review done at some point this week. Now, if you can't make it before or after school, you don't earn the right to retake. That's how it works. You have to spend minimum time with me to go over the problems you missed, and then you can retake. Retakes, there'll be a very similar test. I just redid some of the numbers. That's all I'm doing. Some of you did pretty well. It doesn't matter what your score is. You always get the better of the two. But if you failed it, you have to retake it. I don't think anyone did, but you did.
Like 70-something%.
You get the better of the two scores. That's how it works.
Okay, moment of truth, guys. Get ready, Mr. Ford. Sam's gonna grill you. Oh, don't worry. Take time.
I feel like with homecoming, we should be given like an extra activity to take down. It's pretty busy time of the year.
You gotta what?
Mornings and evenings.
He said he got sick.
I'm just trying to support my school.
It's not bad.
I'm offering
It's too better than me.
What? Oh my god, I'm about to do it.
Yeah. Just my bad.
I
Two
got
hours like what? I got a 78.
You're supposed to be like 80.
If you feel like
Mine
it, should you take the crap?
The first one was the correct answer.
No?
That's
exactly
what I said.
Got this
Because
one.
I did get that answer.
Oh, that was behind the scale.
I got
I
0.5
read it and I was
Blinded by
like,
the lights.
I got zero. You should get a number.
Yeah, I was really confident.
So I realized
And I walked out of this class and I was like,
hard.
some people, and I realized the mistake.
Give me two in
I got that one right.
I did the same as you on the first page. But no. I'm gonna say
You did
no, it's negative 1-0.
What is this?
Did you do the second one wrong?
I got both of those wrong. I got one of them.
All right, so real quick here, let's go through the test questions here. All right, it's out of 41. So, it's out of 41 total. I think practice guide, I think was 40 or 39 or something like that.
Wait, is that in the grade
practice guide, very similar. What?
Is that in?
Yeah, everything was in.
Okay.
It was entered like Saturday. So, all right.
Thanks, Mr. Ward.
So, Saturday like afternoon. Alright, so for the first one, you have to find slope, y minus y, x minus x, you can see my numbers 2, and then I just picked one of the coordinates. So if you pick the other coordinate, fine, dandy, it would have been x plus 1 and y minus 0. But I plug the 2 in, you plug your coordinate that you picked, I picked 2 and 6. Okay, number 2, you had to do perpendicular and parallel. The most common mistake that I saw, people didn't do the perpendicular, they forgot the negative sign. Some of a mistake. You had to use the 2 and the 1, 2 and 1. Parallel, I used the same slope, my slope was 5. I tried to give easy ones, so you didn't have to think about it too hard. The slope is 5. And then the perpendicular, you flip it over and make it negative. So 1 over 5 negative. Okay, there you go. All right, for the next one. All right, so I said out loud that on this number 3 and 4, be careful if it's percent growth or decay. It was actually a decay on this problem because you started in year 2 with 25, you ended year 5 with 15, it's actually going down. So that's the year. So I divide the later year over the former year, right? 5 over 2. Subtract to get 3s, divide these, you get the 0.60. You take the cube root, and this is the number I get. That is the base number, right? It's not 1 plus, it's just that number. That means I'm decaying at a rate of about 15 or 16%. I'd accept 16 because some people just round it. So 15 or 16% decay. I was looking for those numbers, all right? It came down to like, some people forgot to take the cube root, that type of thing. But it was actually going down. All right, moving on. All right, the next one. Some people didn't catch my wording here. This is why I had that PowerPoint. You are decaying exponentially continuously. Continuous is not this formula. That one. It is not. This is the constant rate. I'm doing continuous, which is this one. And if you looked at the PowerPoint, I had this on here. Now, since we're decaying, it has to be a negative number. That's how this formula works. A lot of people didn't put negative. So you missed a point automatically right there. It had to be negative on this formula. It's not like 0 point something. Now, so I think the most common mistake people made other than negative, some people changed this to like a percent, where they moved the decimal back 2 spots. I didn't tell you percent. I didn't tell you percent. I just told you that was the rate. So there's a big difference. So if I would have said 2.4%, you would have done it right.
So, hey, I have a question though.
Yes.
This is a decay of an element.
Yes.
They can't decay into nothing.
They can't what?
It can't be
Hey.
zero.
Now he has scientific knowledge.
they can.
So watch out.
No, it can't because with half-lives it will literally never reach 0.
This is a nuclear element. It's not normal.
Yeah, nice try, Sam.
No, the half-life, that's not how that works. The elements you cannot hit 0.
But this is nuclear. It's a mixture.
Because I did that and I wrote 0 and you can see it on my paper and I thought that's not possible. So I erased
This
it
is
and changed it to a
nuclear.
percent.
it's nuclear. So nuclear is a mixture of a bunch of different things.
Yes, Sam.
Idiot.
No, that's still an element that decays.
Sam, you're wrong.
Strontium 9 isn't.
It's okay.
I made it
Just tell
up.
me it's wrong. Dude. Sam, buddy.
No, you just
Sam, buddy.
you can't get 0.
Shut up.
Alright. Anyway.
Lucy got 0. Lucy got 0.
Okay, so here's the idea. If it was 2.4%, it would not be. But it was decaying at a rate of 2.4 at a continuous rate. Well, that's 2.4. I plug in 100 years, and when you actually plug this in, it decays at a rate where everything is gone. It was literally 0. In fact, if you actually look at the half-life, that's why I had you calculate half-life. If you started with 52 and you went half of it, right? Divide this over, you got half. The half-life is only 0.288 years. That's like a quarter of a year. It's 105 days. So that means that 52 will be half gone, half gone, half gone, half gone. So that's it.
Facilities. Hey, it's the same now.
So it'll be so small that it'll be nearly 0 and they will just round it. There you go. Moving on.
You've gone all day with that. Sounds
This is weird, Warren. This is really weird.
Okay.
When I look up the half-life of strontium 90, which is a real element, I do get back 28.8 years.
I'm gonna ask Mr.
Which is
Oh,
my
it's
answer.
because I didn't put 20. I didn't put
What
percent.
is
Wait, add that to
what you know.
That is literally the dumbest thing. Now I'm mad.
Yeah.
Google is.
Because strontium, now I'm mad.
What? What happened?
I didn't put
Because
percent.
strontium 90 is the element on the test.
Okay.
And he asked what the half-life of it was. 28.8 years. My answer is 28.8 years. And my voice is cracking because I'm very upset.
Dude, I got 28.8 too.
Say.
Yo, I got 28.8.
That's what I got. No, you didn't. Holy
Moving
crap.
on.
Wait,
I literally.
why didn't I get that? I slept so long.
I don't know how.
No.
Now
I got like 600.
I'm outraged. Because I got 28 points.
Hey, you would have been correct if I put a percent on it.
No,
Alright,
that's not a thing.
I accidentally
That
got
is-
the answer.
He didn't ask for the percent. He asked for the grams, and it was 0.
Whams.
I'm
I said
upset.
grams.
alright, moving on. Alright,
I don't want to.
so, alright, if I take G and I plug in a 1, 1 plus 1 is 2, and then I plug 2 into the F function because you're working inside out, you get 2 squared, which is 4. Now, if you did F, the F function plugged in here, that's F with the X squared plugged in here, it's X squared plus 1. And if I did F of 2 and G of 2, 2 in there and 2 in here, I get a 3 and I get a 4 over there. And you multiply those together, you get 12, not 7. A lot of people get putting 7.
I got it.
Alright, because you have to multiply together. Alright, moving on.
1 plus 1 squared
Okay,
Oh my.
is 4.
this function, does it have an inverse? No, it doesn't. It fails the horizontal line test. Number 2, is this even, odd, or not symmetrical? It is not symmetrical, it's not balanced right and left side. 3, is there any intercepts? There is 3 intercepts. There is an intercept there, intercept there, intercept there, on the original function. There is 3, you have to give me all 3. Now, go to the next one. If you have to move this to the right and down.
5 minutes ago, he made that.
So, if you go to the right, 0.5 and down 2.5. Here's where you end up, that's the drawings I'm looking for. Let's move on.
I got that one right.
Said I wouldn't feel that.
Alright, the next one. You have to take the natural log or log, I don't really care which one you
I
took.
got it down right.
So I took the natural log. So this x will drop up front. This one drops up front. The natural log of e goes away. That's why I did it. So I'm left with that. You can actually see it where I did this. And then the idea is what I did is I moved the x across. So I moved, because it was just this. So I subtracted the x over. And then the idea is I factored out an x, because there was 2 x's. You have to factor it out, which is natural log minus 1. Because there's a 1 on this. So when you factor it out, then you have to divide by it. Here's the weird thing. I think I did one of these in like the days when we were doing the homework on this stuff, just to show you the had to distribute. Now, 16. You have to divide the 50 over first, because you have to think with the exponent by itself. You take the log of both sides, and that x drops out front. You can see what I did here, and then I divide this over, and there's your answer. Now, if you gave me the decimal, fine and dandy, but I didn't need it. I said I just need the exact answer. There it is. Some people even put like 0.4 here or whatever. Okay, moving on. 17. It is a cosine graph that is hitting, that is shifted down 4.
I'm sorry that I did it right.
It's shifted down 4. It's going up 8 and down 8 from negative 4. It's a cosine graph, so it looks like a big C. And the 4th hash mark down the road was a pi, because it's 2 pi divided by 2. And then cut in half, multiply by 100. So, there you go. There's your points. It's out of 23, and so on and so forth.
15 confused me.
Dude, I got a 78 on this time.
Alright, free day.
Nope.
You have 78.
Okay.
I'm clueless.
There you go. All right. I'm going to collect them. They're mine. You can retake if you wish. You have until Monday to retake.
I think I might
Come on.
Another thing that annoys me. This is how we're going to do 3 takes on 3.5.
Get a better
Big time.
An intelligent human being would read like Mike. No.
I was gonna put Mr. Warbuck, but that might
Yo,
sound.
I got a 90%.
Yeah, and
Yeah. Are you looking at my score?
Oh yeah, shit, yeah.
I want to see the
So what I'm
problem that was.
Mr. Ward.
So, or
What can you write?
It's kind of cool.
I want to see it.
That we got.
I remember last year intro to
The
chemistry.
difference between the homework problem and when I gave you, I took the percent.
You literally can't do that.
Because I didn't
You
get
can't just
all
say
the X
a rate of
points.
2.4. What that doesn't
Like, there was
even.
one
Last time I
That's not
checked, he
logical.
made the test, so you can really do
I can
whatever
do
you
that.
want.
Oh yeah.
So you can
One extra credit point.
beat science.
But I've still like 102% until one for each.
Mr. Ward.
Oh my gosh.
Are you gonna leave that? Okay, wait, is this okay?
Science of Mr. Ward.
I remember last year I was
I didn't mean
doing
it
some
like
extra credit. I was like, am I doing this right? She's like,
I'm not rejecting.
yeah, you got it. I was like, I did? I remember that.
I gotta see if I can get that.
Literally,
I don't know.
Don't be too serious. Why?
because that is
They're gonna be like,
easily the lowest mark I got on a test.
that's so not even true.
That is- Actually, I did get 83 on 2.5.
How hard is it?
No, remember that chemistry test?
Is it
I got like a 60 on my
multiple choice?
Advanced chemistry is
And you know what? I was so happy.
Advanced chemistry.
I didn't remember.
Which chem was
My
that?
first test.
Watch them from one.
Was that advanced? Oh, I did pretty bad on my test too. Definitely.
What do you guys think?
Actually, no, I don't know. I think I got like.
We're doing
Last time.
Yeah, this time I'm afraid when after I was like
Gas.
disappointed in myself.
Laws. Like Half-Life?
I was like,
Okay, you don't know all the decorations. What are the gas?
But just what's
I might.
I remember I had to come in like the presentation
We're not gonna have.
to make up points.
Just
I got
points
like,
we
that's
need.
why I didn't really take it.
100.
Well, why did you have 56, 100?
Because there's no vocab. Because the first section was vocab.
I remember that. Yeah, I hated that part.
Is he on student council?
Yeah.
There was no calculations on this.
100%. I didn't really
When I
like
was in
I liked the experiments, but I didn't like
It was really second.
the what? I still can't
No,
tune
I'm
Oh,
saying-
that was like geometry.
I just never did retake.
Better than
In the
most
scheme of life,
No.
I mean, it's absolutely nothing.
E. Brown one.
Oh, yeah.
Yeah, I guess what?
Chapter 8,
What are we doing?
93%.
Like, you got out of high school,
That
it
is probably the
Alright,
doesn't matter that you
You said
fail.
what would you do this to yourself?
I had no other class to take. Take it. No.
What's your favorite part about it?
oh,
You like
Camera?
it?
I haven't done night, but I've
Does it
taken
seem a
it.
lot different than your other camera?
No. The camera's better. It's better quality. It just is.
Was it worth
So
it?
is that the only thing that's different about this little phone?
What was the first thing you took a picture of?
Battery life is better.
What's the first thing you took a
got
picture of?
over here.
Step over it.
Yeah,
Picture
step
of
over it.
See what-
Your hydro flask?
Question. Yes. Cross country gotta go.
You gotta go?
You guys gonna leave already?
Yep.
I joined cross country.
Good.
2 minutes.
Sam's gonna
Okay.
be pissed off the whole night.
Uh-oh.
I hope.
Just retake it and stop being so bummed.
I'm not retaking out of principle. I want to.
If I got a 90%, I'd be.
He's gonna go talk to himself.
Correctly.
You got Mr. V to agree with him.
Yeah.
Alright. Hey. Alright.
What are you
So.
doing?
What?
What are you doing?
Where's the?
We have to learn today?
Yeah, we're
After
using
that?
I think I'm scarred from that.
From what?
I can give you
What
homework.
happened?
Oh,
I love when I pick up someone who's so I don't understand.
Okay, so here's what we're going to talk about today. I want to go through a couple pieces of our graphing, but I want to make sure that we understand the basics. So let me give you an example here. We're going to go with 4x squared plus, let's go with 5x, and let's go with plus 1. Let's just stick with something easy. Let's say this is my function. And the idea is what they want us to do is to graph this thing. And so to do all the different pieces. Now, I'm not going to give you graph paper for this right now. This is just to give you an idea of like all the parts we have to talk about, and it is a review of what we did last week. So here's the idea. The first thing we have to do is number 1, figure out, I call it the leading coefficient test. Leading coefficients.
4.
So leading coefficient test. So the idea is that we are looking at kind of end behavior, where the tail's going. So it comes down to, can you figure out where the tails go? Are they going up and down? Are they going opposite directions? What we're looking at is, not only just the power, we're looking at the plus or minus sign out front and figuring out where this thing goes. Okay? So in this particular problem, it's a square graph. That's like my highest power. And it's positive 4. So this thing is going its normal directions up. That's where a square graph goes. Even powers go the same direction. Odd powers go opposites. This is a normal graph of squares. Okay? All right. Perfect. Put it in the back. All right. So now, what we're going to look at next is how to look at intercepts and look at multiplicity tests. We're kind of getting those finer details, but the big thing here is knowing what intercepts are. Okay, intercepts are, where it hits the x-axis to the y-axis. Is it going to bounce off them? Is it going to pass through them? That type of thing. So in my particular graph, I can tell you the y-intercept is really quick. So y-intercepts all you have to do is plug in 0 to all the x's. X is 0, and you plug those all in and you tell me where the y-intercept is. Where is my y-intercept on this particular problem?
1.
1. So I'm gonna hit
Positive 1.
positive 1.
On the y-axis.
Okay,
not the
so yeah, so I'm hitting 1 on the y-axis. Now, next thing I look at is where my x-intercepts are. And this will really tell me if my graph is symmetrical or not, if they're like perfectly balanced from the x-axis. I have to factor that thing apart. Factoring that thing apart is a trinomial. That's how I figure out x-intercepts. You have to be able to factor or do, what we're going to look at tomorrow is going to look at what if I can't factor it, like it's non-factorable. Could you figure out the numbers that would work? So in my case, I'm using a plus because they're the same symbol. They're both pluses, that's how I know. So the back symbol tells me if they're the same or not. I'm breaking up the 4x squared to be 2x and 2x. And then I'm going to break up the 1 to be 1 and 1 and all that good stuff. Okay? Now, what are these numbers that make it work? Well, what are my x-intercepts for both those
Negative
functions?
1/2.
Yeah, negative 1/2, because you said each one equal to 0, and you solve. Now, there happens to be 2 of them, correct?
So it's just gonna bounce
There's
off.
2, so it is bouncing off of them, because it is an actual double root for that one. So that means it's gonna bounce off of negative 1/2. So here's negative 1/2. So that means I'm gonna bounce off of it. So it's gonna literally touch that spot and turn around and go the other direction.
I'm confused.
Question?
Is it 5x though? That's 4x. Factor it. What are we doing?
Oh, you're right.
Oh, Maddie! Maddie is so smart.
I don't know, Mr. Ward. That doesn't look right to me.
See, Mr. Ward, this is a place where you can't
That's
factor.
not
can't factor.
symmetrical.
Just because you...
Okay, so factoring it, I did it
Keep
wrong.
that on tape. Maddie has a smart.
Yeah,
Okay.
post that somewhere.
All right, so it's 1 and 1.
Send it to the president.
It's gonna be what, 4x and 1x? That'll make the 5 in the middle?
Yes.
All right, so that means my 2 numbers, it's not gonna be a double root, so we're not gonna be bouncing up in half. Makes it a lot easier there. We are gonna be going through what, negative 1, we're gonna be going through negative 1/4. So we have 2 different numbers. So negative 1 and negative 1/4.
I think that should get me some extra credit on this.
That's
It does.
something before.
What is that?
It's right.
I've heard it, but I don't know what you're talking about.
All right, so here's my numbers I'm actually hitting, and I'm actually passing through them just because there's only one of each parentheses, it's not a double root. So I'm gonna pass through them. So it looks like my graph is gonna be doing something like this. It's passing through it, coming back through, and then passing through there, and it's heading up in both directions. Now, the question that Brown asked the other day, how do we know how low we need to go on that, that turnaround?
How low can you go?
So it comes down to if we can factor or do complete the square, we can figure out that turning point, but it's also one of the things we're going to look at in the later sections. Like what are the extra things we can do to get more specific on these graphs. Okay, so my x-intercepts in this particular case is negative 1 and negative 1/4. Okay, now, so now that we're done with intercepts, it's definitely not symmetrical. I can tell by where my x-intercepts are. It's not perfectly balanced because they're not on the left and right side. So it's not symmetrical, so I can go on to the next one. So I can look at turning points. So turning point test, my largest power. So my largest power is a 2 on this particular problem. So we go 2 minus 1, so there should be 1 turning point. There was. It went from going down to the right to up to the down to the right and then went up to the right. It changed directions. So it turned 1 time. Figuring out these turning points, this is something that's called an inflection point. We're going to look at that later. Looking at when it actually changed directions. But yeah, those are the main bullets that we're looking at. And can we get a rough sketch of it? Okay, questions on the first one?
Nope.
Okay, now, what are the things I want to talk about?
Well, we don't want to learn anything too new.
And we're missing people.
There's people gone.
I won't be fine.
We're on a do them a disservice.
I don't think I'll be
Yeah,
fine.
that's rude. Kind, caring, and compassionate here at GHB.
That's the only words I know.
Yes, we're ridiculous. All right, okay.
I bet you.
All right. So, here's what we have. Okay, now on this particular problem, we're trying to figure out how to graph, like a rough sketch, right? So the idea is that we'll need to be able to factor this. This is definitely a polynomial, it's not a trinomial. Like, I think I've only shown trinomials for the last ones. So we're gonna have to look at grouping and different methods for factoring. So let's first talk about end behavior.
The tails,
Yeah, where are the tails going?
they are going up.
Both up?
They're no,
No, one's up, one's down.
Okay.
One
they're
is up and one
opposites,
is
right?
down.
So one is up and one is down for the tails. Now,
Wait,
what we
why?
have to figure out is where they're actually going.
Why is it like that?
Because of the odd power, they're
Oh,
going
okay.
the opposite directions. The right
It's not
tail,
symmetrical.
typically, the right tail goes up, the left tail goes down. That is usually how odd powers always work. The only time it changes is when it's a negative out front, then they go the opposite direction.
It goes left.
So
that
yeah,
could
the
be
left
pretty
will go up, the right will go down. So that's just how it normally works. And why I know it's normal, it's a positive 3 up front. That's why I know it's going that direction. Okay, so now, the next thing. Now that we kind of know roughly where it's going, so if I draw a rough sketch, here's what we have. It's something like this. Okay, so this could be origin symmetric or odd symmetric, not even because they're not going the same direction. It's probably not symmetric when I look at the graph. Just because of the numbers are involved, there's a mixture of evens and odds, so it's probably not symmetric if you just think about it.
Probably not.
But factoring it, how do we factor this?
3x
And?
for the 2 up front.
Yeah, so yeah, when you factor, you have to factor by grouping. And you're absolutely right. We have to look at the groupings, we can actually factor. Like the y-intercept stuff, that's easy. Like when I look at an equation, the y-intercept's easy, it's just 8. It's right, it's the back number, it's whatever's in the back.
Yeah.
So I know I'm gonna hit a positive 8. But the idea is that the x-intercepts, it becomes factoring, and you're right, you have to pull out an x squared, right? So I'm gonna be left with an x plus 2. When I pull out that 3x squared from those first two, into the back, a 4, that's what, x plus 2 back here?
Can they group those suckers together?
Yep. So here's what we have. Now at this point, I will not be able to solve for that one side. This side, there's no way I can make this side 0, because you're going to square it, making it positive, and adding a 4 to it. I will never be able to make a negative number there. It's just not possible mathematically. But on the right side, I can hit 0, and I can hit 0 at -2. So it does have one x-intercept.
Wait, can you go through again why the other one can't do it? I think
Because this thing is squared, so like whatever x you pick, any of decimals, fractions, positive, negative, you're going to square it. So it's always going to be positive, right, when you square something. And you're going to add a 4 to it, no matter what the number is. You'll never hit 0, because you can't make a negative. Like if I can make this number a -4 and add 4 to it, I can hit 0. But I can never make this number negative. So it's not possible to get 0 out of that
So
thing.
we just disregard.
Yeah, it is literally disregarded. Like it's not going to happen.
Irrelevant.
So,
This one.
so
Do you have any cough drops?
I do.
Can I have one?
Yes. So, all right. Now, we only have one x-intercept. So,
What
Is
is
it
it?
class snack? That's what I think.
What? Is it class connection?
What is it, class snack time?
Thank you.
okay. Now,
Solid.
so I have one x-intercept. Now, when I actually look at the drawing here, I don't know if it's going to go like, this is the problem with like doing the sketches like we're doing. I don't know if it's going to do something like this and kind of come down and go back up, or if it's already went down and went back up through 8. Like, I don't know where the actual like turning points are. It may not even turn. That's the weird thing. It may be just like a cubic graph by default kind of looks like something like this. So it doesn't have to change directions like radically. And so that's where those other tests in the other sections, like when Brian was asking on Fridays, like, how do you know how far up to go? That's where that next test we're going to learn in the next section will come into play, and we'll add one more test. So we know where.
Yeah.
Because you found the turning points in that one.
Well, this one, the turning points, there was only one, right? And it was a square graph, so we know it just kind of changes direction one time, right? But on this one, it has potential for 2, but it doesn't have to do 2.
It could do that.
It could do 1, it could just, because we know at some point, it's,
Change.
Yeah, it's gotta stay that course by going left to right. It may not have to change direction. So like that's the weird thing is like, I know how many it potentially could do, but it doesn't have to. That's where those other tests we get in the other sections make a big part of it. It is not symmetrical, so I know that. We already figured out, intercepts and whatnot. So it's like one of those things like this is a rough sketch. It's not gonna be the perfect example of it. It may not be the example of it, but it's something that I'm trying to predict by just doing it by hand.
Mr. Ward, you're a good teacher.
Yeah.
Have you ever gotten the Golden Apple Award?
I got it once.
Really? When?
2011.
Really? My mom got it once.
Okay,
So
all
Mr.
right.
Gracious.
Questions with any of that? We're
My
done.
dad never
My
got
mom got to go to the Apple Award. Back in
My
Clear
mom
Lake,
works at
actually.
Christian school.
Back in my day.
She worked at